Hello, this is Professor Sander again, and today we're going to go into our first deep dive, which is the deep dive on the mission model canvas overall. So we've talked about the mission model canvas as we've gone through the last couple of sessions here. We'll go into a little more detail here, and then on a go forward basis, we'll be moving into the different elements or blocks of the canvas. But this still stays at kind of the broad level of the canvas itself. So let's just quickly review mission model canvas. Again, this is kind of the common thread among all of the sessions in the course because it does bring together all nine kind of fundamental elements. And it allows you to not only map out what your current hypotheses are, so your current thoughts, which will become closer to reality the more beneficiary interviews that you do, but also you'll be keeping each one of your canvases. And so you'll have a kind of a historical pathway from where you started, which is now, you'll do your first canvas here very soon, to where you ended up. And so you'll see how your thoughts evolve, primarily as you were able to get feedback from other, from beneficiaries, whether it's through, primary research contacts or secondary, people that you found that you thought might be able to add to the equation, and so on. But again, as you go through this is the common element, right? You'll be moving from problem to the value proposition, the proposed solution, and then to deployment. And all of this is iterative, right? So there's no go to one block, figure that out completely, go to the next block and forget about what you've done before. The beneficiaries, what you think their needs are, will certainly affect the value proposition. The deployment could affect the budget. The key partners could affect buy-in and support. So the whole process is very iterative, but it really is founded on this concept of the canvas. And it'll be the basis for your student presentations as you go through this semester. So let's start with the success story. And this was a success story that came out of Stanford University. One of their hacking for defense teams, a team called Anthro Energy, in 2020, this team, there was a PhD and some other students on this, and they were looking at changing the future of battery technology. The problem that they got from the Joint Operations Command was essentially the problem of ejected pilots from aircraft. So, our war fighters in the aircraft on occasion had to eject, as they got into difficult situations, they would, hopefully eject safely to the ground, parachute to the ground. And then those ejected fighter pilots needed a certain amount of energy in order to power their systems and to increase their chances of rescue. And so this team, After Energy, was essentially given the problem that I just described. You have ejected pilots, they are down potentially in enemy territory, potentially injured, and they need to find the most assured way to essentially be rescued and to keep, whether it's a homing beacon or whatever it is on the whole time. And so the student team went through 143 discovery interviews. Okay. And what's interesting is as they went through this and they spoke with many pilots, what they found is the pilots, those that ejected, those that hadn't ejected but could project themselves in that situation, said their primary concern was not really energy. It wasn't battery power. It was simply survival. So they were really very, very, very focused on survival, and battery power, and was not really a challenge. The problem is that as you eject, there's a certain inventory that you carry with you to try and help you maintain life, and so batteries are heavy, bulky, get in the way, and so there is a natural downside to that as you're going through that process of ejecting and then hopefully landing. And so, but they kept going. The team kept going, and what they found is that there was a specific life-saving group. So the DoD used to send out, would still today send out rescue teams, and those rescue teams would then essentially parachute into the area of the ejected pilot, and they were in dire need of battery power because all of their systems, they were on search and rescue. And so, the ability to have battery power that gave them all the energy they needed to basically use every sensing system that they had was critical to them. They had the same challenge. That is that the batteries are heavy, the batteries are bulky, the batteries are not many times sized for what you needed. And so this team, and they had experts in battery power, one of the things that they had been developing is essentially a moldable battery. So something that could mold itself to the shape of the body and therefore be less obtrusive as as whoever was carried it. So interestingly enough, what they found is it really wasn't about the pilots didn't feel the same need that the team was given, but certainly the rescue team was looking for this and looking for every bit of it that they could possibly find. Now, so the team went through this, the student team. They discovered this, they went through the whole thing, they did a minimum viable product. They got to the end of the semester. And what they realized is that there are incredible dual use applications for this. So dual use is a term that essentially says, look, if I'm developing a technology or a solution set of some kind for the military, there could be incredible applications outside of the government. And so dual use would be for the military market and also for the commercial market. And so obviously, if you think about people going into difficult environments where they need excess battery power, but they also need to maintain some form function so they could, as an example, in a rescue situation in caves or hikers, you can imagine multiple scenarios where they need that. And so post the course, this team went into a program called HParks Labs and essentially continued on and developed this for dual use venture applications. A couple of team members now work full-time at Anthro Energy, and one of them was honored as a Forbes 30 under 30 honoree. So this is just an example of the kind of power that you can bring to this, but also an example that examine the problem you're given. So the problem may focus on one particular element. In this case, it was battery power for ejected pilots. So that if the team kept going down that route, they would never come to this kind of a high value solution. You really have to question the problem as you go along, because that's part of what this program is about. That's part of the value that the military and the intelligence agencies see in this kind of a program. So that really is the key message here is really focused on what is the overall problem. You'll be given certain assumptions in the document, and those assumptions may all be true, but it really is helpful to kind of go through the process and in your mind, at least challenge those and then include those in your beneficiary discovery questions. All right, so essentially what you do is you use the mission model canvas to frame your different hypotheses, not only in beneficiaries, but the value proposition. So you can see, and I won't go through every word on here, but if you just look at some categories, we talked quite a bit already about beneficiaries and stakeholders and the value proposition. Think about, for instance, mission achievement or success, right? What you'll be asked to do as we get to that block is not only define mission achievement or success for the person that is actually the user of the technology. So in the example as we went through, the person who is the user of the technology was the ejected pilot. That was the vision, right? That the battery, the increased battery power, the increased energy supply would essentially benefit that person most directly, and then obviously benefit others as they were looking for that person, okay? But mission achievement, as you'll find when we go through it, really goes all the way from the person on the ground who's being impacted by the solution that you're going to propose, all the way up to the presidential level. So mission achievement is not just for the individual. It's not just for the company. It's not just for the battalion. It's not just for the Army, Navy, Air Force, Marine, Space Force. It's also at the national level. And so as you think about this, and you'll be led through these discussions, it's really important to understand that mission achievement has to be really realized at all of these different levels in order for you to come out with a deployment tactic or strategy that allows you to really take this incredible solution that you may develop and find the strategy to be able to get buy-in and support from all those different levels so that you can ultimately deploy the solution. So hopefully you start to see now how all of these things start to fit together, and you'll be doing that iteratively every week as you go through the different blocks here. At first, you're going to have guesses. I mean, that's what it is. Remember the concept of get out of the building, because there are no answers in the building. So at first, what you'll do is you'll populate your mission model canvas, and you'll do that this very soon. And as you're doing that, you're going to take your best guess based on your knowledge, maybe a little bit of research, certainly what's in the problem statement from the sponsor, but you're going to guess who the beneficiaries are and what are their real pain points and what do they hope to gain out of this. And your entire canvas will be populated with hypotheses, guesses, until you actually go out and do the beneficiary discovery. And that's when you'll either validate or invalidate or partially validate those hypotheses or guesses. And every time you do, you're going to change it to something that's better, because frankly, it's now informed by 1, 2, 3, 10, 100, whatever the number is, beneficiary interviews. So that's the power of this process. And that's how you link together the mission model canvas with the hypotheses, with the interviewing, and then you'll bring the minimum viable product into this, because as you start to narrow down your understanding and sharpen your understanding of what is really the problem, what are the pains and the potential gains that the beneficiaries, plural, are seeing, and then how do I develop the value proposition around that? And I start to think about, okay, if that's part of the equation, who has to be in that chain? Who has to buy in to this process if this were going forward for real? And again, you have opportunities even after the class to take this forward. There's a section of information as part of this course that tells you about some of the additional resources, financial and support and otherwise, that you can take advantage of post the course. And me, anybody wants to move forward, talk to me. I'll work with you. I'll get you the help we can. So these really are all guesses to start. And then the process through the semester is take guesses and turn them into, if not fact, then as close as fact that you can get, because you're going to be doing these beneficiary interviews. So a couple things to then leave you with. The mission model canvas, in order to the project be successful, essentially it has to meet many criteria, but 3 primary ones are desirability, viability, and feasibility. So desirability, and you'll see how this matches up to the mission model canvas in a second, really tests whether this thing is solving the right problem and a valuable problem. In other words, is this really desirable to the beneficiaries, all of the beneficiaries up and down the chain, not just to the end users, to the Air Force, to the neighboring communities, to whatever it is. Right? So part of the mission model canvas, as you'll see here in a second, is really designed to explore desirability of a solution set to a problem set. And are there people there that desire that will buy into that, and that'll support that, and support the deployment of that? Feasibility then is really a test about whether it's possible in a given time frame. Okay. And so as an example, can one undertake the kinds of activities, form the kinds of partnerships that they need to form in order to really look at, could this thing be deployed to the benefit of all the beneficiaries and mission achievement in the kind of time frame that is reasonable. Okay, if it's a 30-year project, it's going to be very difficult. If it's a 2-year project, maybe it may not be you that deploys this, but it may be the agency or somebody else following up on this. Or as an example that we just talked about, it may be a company that comes from this. You may be part of that company, but essentially it's looking at now, okay, is there a commercial and a military opportunity for this? And viability is really about long-term sustainability. In other words, part of this is, do the numbers work, right? Does the budget work? Does it really provide long-term mission achievement? Okay, and so let me, if I could, show you for a moment how that maps out to the mission model canvas. Right, if you look at really the bits of the 4 blocks that are in the upper right-hand portion, it's really about desirability. Do you have a value proposition? Can you get buy-in and support along all of the avenues that are necessary to essentially support what you're doing so that you can provide significant value to the beneficiaries? And can you actually deploy that? And as part of that, can you show mission achievement and success? Feasibility, which is the 3 blocks more on the left-hand side, to a degree, budget, mission, budget, and cost, so they bleed over into each other. The feasibility is really, okay, are these activities and the resources that are necessary feasible? In other words, are you proposing, as an example, a solution that would cost $100 billion right off the bat to get out the door? Are you proposing a reliance on science or technology that's maybe 6 generations away from where we are today? If you, for instance, if you're looking at some type of a nanotechnology solution, could you get the key partners on board? Do they exist? And then in terms of mission budget and cost, is that reasonable in terms of what you're trying to accomplish? And that's difficult, because if you look at viability, the sanity check, you're balancing things like people's lives against mission budget and cost. Right? The military has to do that all of the time, right? But that's what's required. It requires a kind of a reasonableness check for these 3 elements. Is it desirable? Is it really feasible? And is it viable in the long term in order to reach success? Okay. So hopefully this gave you a little better feel for the mission model canvas at a slightly deeper level. We'll be going into all of the different elements as we go along in the coming weeks throughout this class. But again, from a high level perspective, hopefully what you got is a deeper level of understanding. And then as we go through future deeper dives, which is the presentations to come, you'll get an even deeper understanding of the individual blocks. Thank you.